Okay, then let me just start the next session, that is your filter design using Scilab. So the filter design, we say that there are two types of filter. One is your digital filter, another is your analog filter, right? Analog filters that uses the inductors, capacitors to produce the required effects, and digital filter uses the modern processors for doing the same. So for using the filter, we use the filter command, right? We use the filter command as you know that when we want to design the filter, we have the two portions. That is your in the transfer function, we have the numerator as well as we have the denominator, and then the input signal, the signal we have to give. This is numerator and denominator is the function of the filter function we have to give, right? And after that we input the signal and finally we get the filtered signal. So that's why y is equal to, we are giving filter numerator comma denominator comma x. So this is the command that is your numerator and denominator and x. Okay, let me just try, I want to access the according to that. Let me access that. I will go to any other this thing, and that is your MATLAB 4 or MATLAB 2. Let me just try that. I'll go to MATLAB 3 and then password. So Jitendra, you must be getting such type of message. So I am opening in parallel HTML5 client. So this is my MATLAB 3. I have double clicked it. Now the password, that is your just 1 minute. प्रदीप प्रदीप कहाँ पे हो प्रदीप एक मिनट आना जरा वो मैटलैब 3 में ना अंदर जाके कुछ पासवर्ड मांग रहा है वो ओके ओके जस्ट 1 मिनट प्लीज मैं फिर शो कर देती हूँ कि कैसे कनेक्शन होगा because anyone can use it at night also you can use it and you can practice with this method. मैटलैब 3 मैंने दबाया, मैंने वो भी किया NITTTR@123। उसके बाद अंदर जाके अगेन इट इज आस्किंग दिस यूजर नेम एंड पासवर्ड मैटलैब 3@workgroup/win-1। इसको क्लिक भी नहीं करने दे रहा।
ये क्या चक्कर है? मैटलैब 3 पे तो नहीं होना चाहिए। अब देखना मैडम मैटलैब 3 पे दोबारा से।
एक सेकंड,
मैंने वो वहां से लॉग आउट किया।
वहां से मतलब
वहां लॉगिन कर रखा था ना एक बार।
अच्छा, लेट मी जस्ट सी मैटलैब 3 एक्चुअली मैंने सोचा कि मैं एक बार ट्राई कर लूं। ही इज गेटिंग एवरीबॉडी इज गेटिंग द सेम। उसका अपना सिस्टम का कुछ है कि नहीं है, जस्ट चेक करने के लिए मैंने कहा कि वो चेक कर लेते हैं।
ये क्या है लोग?
और कुछ देखो मैटलैब 2 वगैरह।
देखना दूसरे पे किसी ने। लक्ष्मी से पूछता हूँ। यूज ऐड डोमेन।
या इंस्टॉल ना करने के लिए, इंस्टॉल ना करने के लिए
नहीं वो तो दूसरा
ये करो ना।
हाँ यही है ना।
2 तो चल गया। ओके 2 तो इट इज ओपनिंग।
ये मैं कुछ प्रॉब्लम है इसको।
हाँ सी जितेंद्र।
Yes, ma'am.
I am using this MATLAB 2. It is perfectly working.
Okay, ma'am. So maybe
I have used MATLAB 2. I have used. Now it is perfectly working. I don't know from your system, maybe some problem is there. So the Scilab window I have opened, and here if I want to write anything, it is working perfectly. You see, this is the another system I have accessing.
तो मैम अभी मुझे क्या करना होगा मैम?
आप
मैटलैब 2 से कराओ।
मैं एक बार मैटलैब 2 को मैं ऑफ कर रही हूँ, डिसमिस कर रही हूँ। आप एक बार जस्ट ट्राई कर लो मैटलैब 2 में भी फिर से ऐसे मैंने जैसे दिखाया ऐसे विंडो आ रही है आपको?
हाँ मैम, ऐसी विंडो तो आ रही थी मैम।
फिर ये आ गया था मैटलैब 2
भी आ गया था मैम। इसके बाद में डेस्कटॉप भी खुल गया था मैम।
ऐसे डेस्कटॉप भी खुल गया था ऐसे?
यस मैम, ऐसे डेस्कटॉप भी खुल गया था। आइकन पे, बट आइकन पे क्लिक करने पे
आइकन पे क्लिक करने से वो खोल नहीं रहा।
हाँ, जूम इन जूम आउट हो रहा है बस मैम।
ऐसा डबल क्लिक करने से ऐसे नहीं खोल रहा था। ओके
हाँ मैं ऐसे नहीं खोल रहा था।
अच्छा यहाँ पर तो खोल रहा है सारे, मतलब इट इज एक्सेसिंग। ठीक है, दैट मींस उनका सिस्टम पे कुछ होगा। एक बार ट्राई कर लेना, मैं मैटलैब 2 ऑफ कर रही हूँ जस्ट टू चेकिंग पर्पसेस, मैंने इसलिए ऑन किया था। ठीक है
जी मैम।
मैंने ऑफ कर दिया, आप एक बार ट्राई कर लेना। ओके सो आई विल गो टू माय Scilab and I will just see that what do you mean by this filter command, right? So this is my numerator and denominator, any value you can put, and this is my input signal. So if you want that this is your filter signal, and if you just input this into the sine nodes, and if we execute this, then automatically you see you will get some plot that is your filtered plot, right? This is your filtered signal. Now I just want to say that what do you mean by this filter, and what are the different types of filter are available, right? So filter, when we say about the filter, so there are mainly 4 types of filter are there, right? There are 4 types of filter. One is your low pass filter, LPF, another is your high pass filter, another is your band pass filter, and another is your band stop filter, right? So low pass filter is your you pass the low pass low frequency and you stop to pass the high frequency. This is your low pass filter. And high pass filter is your that you just cut the lower frequency and you pass the higher frequency components. That is your high pass filter. Band pass filter is your that you pass the some band, and after that the other portion of the band you just stop passing. And band stop filter, you say that opposite, that in this band you are stopping the this is your band stop, that you are stopping the signal to pass, and the other portion of the band you are passing. So these are some 4 types of filter. So another term is there, that is your FIR filter and is your IIR filter. Now these 2 terms is there. Now what do you mean by this FIR filter and IIR filter? By name only you can understand that is your finite impulse response. This is known as your finite impulse response filter. And another is your high pass filter, that is your IIR filter, that is known as your infinite impulse response, right? Infinite impulse response. So this is your finite impulse response and infinite impulse response. Now what do you mean by the finite impulse response? I have told you impulse response is what? That is your HN, that is your f of delta n. So that is your function of delta n, or the response of your output of delta n, y of delta n also you can take. So that is your HN. Now, if in your HN, that is your impulse response, if there are the finite values, so this is known as your FIR. If the HN has the finite values, then we will say that is your FIR filter, that is finite impulse response filter. IIR filter is what? For example, that in that HN, if you have the infinite values. For example, we are telling that x to the power n un. So un means it will go up to infinite, right? It is unending. So there you will get all the values as your infinite values. Hn doesn't have the finite values. That time we will say that is your infinite impulse response filter. So if we want to design that FIR, FIR LPF, that means finite impulse response, as well as the lower frequency, pass frequency also. So if we want to find out the lower pass frequency, so what do we want? We want one cutoff frequency, right? That is known as your FP. So FP is equal to, we are telling that input, enter the cutoff frequency in hertz that we are inputting. That is your cutoff frequency. And N is equal to is your order of the filter. And F is your, we are getting that the sampling frequency. Though these three input we are taking, one is your cutoff frequency, another is your order of the filter, another is your sampling frequency. These three terms we want, right, when we want to design. Another thing is we have to find the normalized frequency. When we will say the normalized frequency means that is your FP by F. FP is what we know, that is cutoff frequency. F is our sampling frequency. So that we have to taken out, that is your WC, because in case of the command, that is your WFIR, why it is W, I will just tell you. WFIR, we want this WC and 0. This is your constant values, right? Since it is a normalized and the constant value, so frequency by frequency, it will give the constant value, for example, 3 or 2 or 1 or 0.5, anything else. So this is your constant value you require. So that's why we say that it is a normalized frequency, a normalized frequency. So this we have to find out. One is your cutoff frequency we have to enter. We have to enter the order of the filter. We have to enter the sampling frequency, and this we have to carry out that WC equal to FP by F. Now the filter command. Now why it is WFIR? Because FIR can be designed with the help of the windowing technique. We use this technique that is known as your windowing technique. There are so many window technique can be used, right? Here we have used the Hamming window. That's why it is known as your HM, right? Hamming window. You don't have to remember that what should be is your, if it is a Kaiser window, then what should be written. When you will take the help as WFIR, it will tell you all the windowing techniques and its constant, that what you have to enter. If it is a rectangular window, what you have to enter. If it is a Kaiser window, what you have to enter. If it is a Henning window, then what you have to enter. If it is a Bartlett window, then what we have to enter. So it is already there in the Scilab, right? You don't have to remember. But it has been found that if we use the Hamming window, then the filter responses gives it gives as a smoother window. So smoother, the graph. So that's why we use the Hamming window mostly in case of the windowing filter design. So first of all, in this that is your command, we have, that is your, first of all is your LP, that is mix, that is since it is a LPF, matlab low pass filter, so it is LP. If it is a high pass filter, then we give the HP. If it is a band pass filter, we give the, if it is a band pass filter, then we give the BP, and if it is a band stop filter, most probably we give the SB, ulta, right? That is the SB, not BS, it will be SB. So this is your LP, that is your low pass filter we want to design. We want to design FIR filter, so it is a WFIR. Then we are giving the filter order, that is your N, whatever we have given it will take. Then WC, 0. Now what is 0 and why it is WC? That is a point, right? Since it is a low pass filter, so first of all we are giving that that frequency, that is your WC, because FP by F we have found out. Next value is your 0. If it is a high pass filter, so what we will write? We will write FIR. Here we will give the high pass filter, a comma N. Here we will give 0 WC. right? That is your for the high pass filter. If it is a band pass filter, so we will write WC1 and WC2. If it is for example, here you will give BP, and if it is a stop band filter, then we will give FIR, WFIR will give SB, and here also you will give WC1 and WC2. This is a matrix, right? This is a matrix form. After that, whichever window you want to create, that is your HM. Next one is your ripple. A W00 matlab there will not be any ripple factors. So we are giving the 00. So we are getting that this is actually WFIR, that is your filter. And what it is coming, the output it is coming is your filter coefficient, that is your COEFF well. Here you will get the coefficient. Then you will get the frequency of the amplitude of the frequency component and frequency of the frequency component. That means if you want to draw the frequency response, just 1 minute. Yes, if you want to find the frequency response, then we want that frequency amplitude and the frequency component. So that's why we are getting that F amplitude and F frequency. So here we are, we are finding the frequency response of the filter. That is, we are plotting the frequency response. And finally, that is actually basically the FIR low pass filter. Now I will just show you, right? I'll just show you this equation. In the Scilab, I will just draw, right? And in execute, we were drawing. Okay, so input the cutoff frequency I am giving. Cutoff frequency may be 20, right? Enter the order of the filter. So I am giving 8. Enter the order of the filter. I am giving 8. Enter the sampling frequency. Sampling frequency maybe I am giving that 100, right? Okay. So it must be it must have seen the output, no? Okay, let me just see why it is. FP is your okay, let me just see again. 50, then is your 8, then is your say 100. So plot 2D, it should come. Output, it is not coming, no? Stop. Just let me check that why the output is not coming. Okay, so it was actually semicolon was there, so it was not outputting the result, because in the code I had put semicolon here. So I had told you yesterday also, if it is a semicolon, then it will not execute in the command window. So we are getting this low pass filter, that is your FIR low pass filter, that is your X title we have given. And you see that X level text, that is frequency, Y level text, that is magnitude. That's why we are giving this A and GCA, so that we can handle the the axis. And basically what we are giving that I suppose 20 we have given in the output, that is your, yes, cutoff frequency we have given 20, filter order n, and the sampling frequency 100. So in the 20 only we are getting the 20 means 20 by FP. FP we have given as 100. So 20 by 100 is your generally 0.5. So that's why in the 0.5 only we are getting the stop band frequency, that is your cutoff, right? WC, right? FP by F, right? That is only we have given FP by F. So that's why it is giving into the 0.5. We are getting the stop band, that is your cutoff we are getting. So such type of signal you can draw. Now we can just change it into the high pass also. So let me just change it into the high pass. Right, we will give that here, we will give the HP, and here we will give, for example, 0 and WC, right? And Hamming window only we are using. Here we will just change into that. This is your high pass filter. Here comment is also, let me give as a high pass filter. For the comment we give the two slash, right? That will give you the comment, right? So now let me just execute. So it is executing again. The higher frequency is your 40, for example, 8, and then is your 200 or something 100 also you can give, right? It is giving some error. So WC coefficient error 10, wrong value of the incoming. Okay. Let me just check high pass filter. Okay, I have given that as you know, just 1 minute. So let me just take help for WFIR, that I can just see that where my problem is there. So this is my window. I have given that HP as your high pass filter that I have given. W type Hamming window that I have given, 2 vector cutoff frequency, that is also I have given. 0 C frequency less than 1, C frequency less than this IPI is used when F type is LP or HP. Okay. C frequency 1 is greater than 0, C frequency 2 is less than 0.5. Okay. So let me just see it is not less than 5. So let me execute again. FP by F. So 20 I have given, 20 by 100.5. Okay. 20 by, I can keep as your so WC. Is giving some error. Maybe some values is different. I think so. Some it may some discrepancy in the values it is giving. Most probably like this. Otherwise, there is no problem in that. I think so. There is no other problem because formula and the command is right. Okay, let me just check whether it is WC0. Maybe it will take as your WC0 only. Let me just check it, please. Why it is coming error? Just I want to check. No, there is some other error. Okay. Okay, I'll just check it, and then the tomorrow I can in the second half, that is your practice session also, I can tell you that what is the problem. Let me just check out that one, where is the problem. But generally the command is this only, that is your, if you want to design the high pass filter, then you have to use this WC and 0. I will just check it and I will just confirm you that where I am wrong, right? So this is actually FIR low pass filter, and similarly you can create the IIR filter also. So IIR low pass filter is your to create this IIR command, that is your for infinite impulse response. Here also we use this cutoff frequency and your higher order of the filter, sampling frequency, same thing, right? But in the sense here, when we use this IIR filter and the low pass filter, we design, if you have, because many of you are from electronics background, so you must be knowing, to design the IIR filter, we use some analog filter. Analog filter means you can use the Butterworth filter, you can use the Chebyshev filter, or you can use the elliptic filter. So now we are creating with the Butterworth filter, and we are giving WC0 and 00. So otherwise other things are same. Here we have used just you know that that coefficients we are getting in HZ, and from the coefficient itself you can find out the frequency magnitude and the frequency component. So that's why we are using the FR mag, that is your frequency magnitude, and from the HZ we are taking the 256 frequency points you want to find out. So we are directly getting the frequency points, and finally we are that plotting. Now let me just copy it, and again I will just paste in the Scilab window, and let me just execute it. Now again it is asking me that what should be the cutoff frequency, what should be the order of the filter, and what should be the sampling frequency. And you just see that you are getting this IIR filter, that is your Butterworth filter, right? Now if you want to find out the other filter, for example Chebyshev filter, or for example the elliptic filter, that also you can do with the help of this Chebyshev filter. For the Chebyshev filter we write CHEB1, where we get the passband ripple, right? And for Chebyshev 2 we get the stop band ripple, and for this we use the CHEB2. For elliptic filter we use the ELLIP, for which we get the passband ripple also, as well as the stop band ripple also. Now what is the ripple? As I have told, here you have to give that ripple values, right? For example, if you want to use that, here I will change that. If we want to use the Chebyshev filter, right, we want to use CHEB1, right? Chebyshev filter we are using WC0 because it is a low pass filter, and here we are using for the Chebyshev filter we are giving that passband ripple is your 0.1, right? Now if you want to if we agree, so it is asking that enter the cutoff frequency again, enter the order again, and enter the sampling frequency again. Now you see the ripple, it is coming. This is your Chebyshev 1 window, right, where we can give the passband ripple, and then we are finding the Chebyshev filter. Now if you want the Chebyshev 2, say in the Chebyshev 2 what we get the the stop band ripple. So in the passband ripple we are giving that 0, and in the stop band ripple we are giving 0.1. Now if you are executing, again we are getting that cutoff frequency, that we are giving that 20, then order of the filter 8, and this your sampling frequency is 100. You see we are getting the low pass filter, but we are getting the Chebyshev filter 2. So this is your IIR filter design with the different filter. And if you want to give the elliptic filter, then you have to write that ELLIP, and here you have to give the both the ripple. So 0.1 and 0.2 is 0.1 also you can give. It is not mandatory that you have to give the same ripple, right? That is not mandatory. So we are giving 8 and this is your 100. So we are getting, this is your elliptic filter. If you just check with your filter design book, Salibahanan or in the Procase, then you will get this type of filter and it will be similar as your different types of elliptic filter, Butterworth filter, then is your Chebyshev filter 1 and Chebyshev filter 2. So this is your IIR filter design, and I am giving you this PPT also I am sharing with you. So you can do the practice session on this filter design. Only one thing is that I will just check with the that high pass filter, and I will check in the next half. That is only of course into the practice session, but I will be joining with you, so that if you find any difficulty in the practice, so I will be immediately I will solve. And in that practice session only, I will just check the high pass filter, what it is the error, and I will tell you the error in that. It should not give any error in the program, but most probably for the values only I am getting the error. It is my view, but anyway, I will just check it up and I will tell you. This is only high pass filter we are using, WC0 and WW. Okay, this is same only. We must be giving some error in the value, I suppose. So that's why we are getting. So this is something about the filter design, that is your FIR filter and the IIR filter.